So that basically wraps up the presentation of the webinar session. So let us now move to the panelist discussion session. Joining us as a panelist today, we also have Prof. Olaf Weston, a professor in microbial ecology at the NTNU University, and Dr. Peter de Schrijver, the R&D group leader on health and environment in whey aquaculture, both who have been very active on microbial management in aquaculture. Okay, let's start the ball rolling. So basically, I've compiled quite a number of questions from the registration and also from the chat box. The first, it is more on, when it comes to microbial management in aquaculture. So basically, everyone is wondering, can this really be done? And would it be stable enough and sustainable enough in future? Can we really stir the microbial diversity to our needs? Probably Patrick, you can comment on this first. Either we can, yeah.
I think we have seen a good example today on research experience, academic experience, and field application. I think we have heard it from the different speakers, there is big progress in understanding what went wrong in the past. I think we have seen very good examples on how things can be improved. The mature water, the application of simple RAS systems. And I think this is a very positive step for a more sustainable shrimp farming and maybe aquaculture in the future, where we are going, and maybe that I'm simplifying the things a bit when I say where we are going from a pure monoculture to a more integrated farming. And integrated farming can be at different levels. The integrated farming can be with different species, as we have seen by different speakers, or can also be by proper microbial management, which I also call a kind of integrated farming. So I don't know if this is a good answer for the person who was asking the question. I think our knowledge is improving. Applications are definitely on the way forward, but I think we still have a way to go. We have to learn more and see how we can further improve things. But maybe other panel members, I see some hands up. Olaf might be the first one.
Yes, when I started working on these microbial management things in the early 1990s, most people had in a way something of the same comments. They said that you can characterize the microbiota, but you cannot steer them. There are too many and it's too complicated. But now we have been working with this for 30 years, and there is not a single experiment we have done where we have been disappointed. And as Kari showed also, the effect is often dramatic, maybe a factor 2 increase in survival and things like that. And we were working a lot on turbot rearing in the 1990s, and I remember at one larvae conference in Ghent, Kjell Inge Reitan showed experiment from more nutritional experiment that we have been doing, and we had 30 to 40% survival during the larval stage at that time, and people were very surprised. And then that was not in a way microbial management experiment, but we used the microbial management in more nutritionally related things. There is one warning in this, and I think like many other things, the microbial management, like the larval rearing, is knowledge-based. And if you have some kind of idea about how this should be done, but you don't have a proper insight into how this really works, microbiologically, then you can easily run into problems and say that this does not work. But as Kari said, it is easy to operate it, fairly simple, and it's very robust. So I think the answer to the question is yes, we can do this, but it requires knowledge both as the platform for making a microbial management strategy, and it requires knowledge from the people that are going to implement it.
I can imagine that it is easier to have this microbial management system in hatchery compared to big farms, outdoor ponds. And we do have a question from the audience here in terms of the possibility of applying effective microbial management in big shrimp farms, such as in Bangladesh. So what do you think? Is it really possible if we have big shrimp farms? And
in my opinion, the bigger, the more complicated. But it depends also in the degree of reuse of water and water exchange, because if the water exchange is limited, so when I have been talking about this, I have had similar questions before talking to salmon growers, and of course, in a net pen in the ocean, you cannot apply this. But I think in a shrimp pond, well, my background on shrimp ponds is very, very low. But I will say as long as you have control over the water exchange and the water exchange is low, then it should be possible also in these systems. But of course, it will be much more easy if you have a covered system, some DO coverage compared to when it's open, because like seabirds and other animals can contaminate the systems very quickly if they are allowed free access.
I can see that Kari and Manuel is also raising their hands. Maybe Kari, you want to comment on something?
Yes, I want to comment on that question, because I think a bigger system is, like Olav said, maybe more challenged in a way, but if we don't think about it so complicated, microbial management is also stop doing the stupid things and know if you are doing stupid things. It's not all about doing the correct things. So I think at some level you could increase the management just by knowing, having knowledge and knowing how to not do the stupid things at least. And that would probably also increase. And then you could advance from that. And so I think at some level, it will still be possible to do improvements just by knowing what not to do, also in big systems.
How about you, Manuel? You want to add something?
Yes, because it's actually right. I think just if we could have a better understanding on what we are dealing with, understanding that when we exchange water, it's maybe not necessarily a good thing. Understanding that the feeding is not only feeding the shrimp, but feeding the environment. Having these principles understood and knowing that there's not only shrimp and feed, we don't have to go for 100% zero water exchange microbial systems in Bangladesh tomorrow, but just integrating those notions, I think will possibly make a better approach when it comes to how to develop the industry, for example, in Bangladesh. The new farms to be built, should we build 10-hectare ponds or small ponds? Obviously, if you're having large ponds, the control you will have on your environment will be lower, because you cannot exchange as much water, because your tools and this dynamics is much higher. So, but it doesn't mean that we can just say, okay, forget about it. This is not the right thing to do. I think everybody here, we agree that this is a very nice, robust tool. So how to integrate it, think about it, what can you do about it? It's not one single answer, but there is definitely things to think of there.
Thank you. Okay. So now let's move to the second question. Oh yeah, Peter. Peter wants to say something too?
Yeah, I wanted to add to what Kari, Olav, and Manuel were saying is when you think about microbial management, it's all about principles. It's about understanding the ecology behind what happens at the microbes, because I see also now a lot of questions popping up like, how can we get this bacterium in place and how can we get this bacterium in place? It's not about the names. It's not about which bacteria exactly are there. It's about which groups of bacteria are there, and the heterotrophic ones, the autotrophic ones, the fast growers, the slow growers. It's not about specifically a Vibrio harvey or a Campbelli or a Bacillus subtilis or a Bacillus megatherium necessarily. It's about ecological groups, and I think this is very important to know. But it still represents, like Kari says, understanding what should be done and what should not be done, not from individual species point of view, but about groups of bacteria.
Okay, so going back to the understanding the concept of this microbial management. So let's have a look on the process. Actually, when we're looking at, managing this microbe, what actually we should manage? Is it a type? Yeah, just now Peter mentioned about, understanding the ecology, looking at the groups that are responsible for the activity. Is there a specific type? No, actually, in terms of the management, does it really depends on the species, number of species, its composition? And then it comes to the second question in terms of application and maintenance. How can we, what can we apply to beneficial microbe? Should we seed specific microbes every day or once a week? Or play with the carbon source addition? Is it good enough? What is actually the best practices? Or maybe I should rephrase again the question. It's more on, understand, how can we apply? How can one apply and maintain whatever microbes, all the beneficial microbe that they already have in their system? Okay,
Maybe yeah, I can give a start, and then maybe the other ones can jump in. I think it's very important to realize when you talk about microbial management is that it's the environment decides which bacteria can be there and which bacteria cannot be there. So, and that's why I said it's very important to understand the ecology of what they're there. If, like Manuel says, if you have an environment where you add a lot of molasses and there is nitrogen coming from the shrimp, you will have heterotrophic bacteria, you will have a lot of bioflux. If you don't add the molasses and you have a lot of nitrogen, it will be mainly selecting for the autotrophic bacteria, for the nitrifying bacteria. So how can we do that? How can we select or determine which bacteria are there? It's by changing the environmental conditions. But at the same time, realizing that when you add feed in your ponds, when you add shrimp feed or fish feed in your ponds, it also represents nutrients for the bacteria. So we should understand, as it was said before, it's knowledge-based, it's understanding what's happening at the level of the microbes, and that everything that we do, water exchange, adding feed, removing nitrogen in some way, it all has an effect on the bacteria. When people, for example, they add probiotics, and they have been adding probiotics for 20 years already. In the beginning, it was all about we need to add good bacteria. Now, in my opinion, the most important thing about adding probiotics is that we know that we are not adding harmful bacteria. They have been selected for some features, they have been selected for some positive effects on the animals, which is good. But to get the maximum out of the use of probiotic bacteria, we should also understand what are the conditions that allows them to survive in the systems. Maybe sometimes people are using practices that they add probiotics, but at the same time, the conditions make that they will go out of the system again within very short notice. So it's kind of wasting money. And that means that by knowing what you do, you can increase the efficiency of practices that people have been using for a long time.
Okay. I can see Olaf and Kari is also raising their hands. Olaf, maybe you want to add?
Okay. In some ways, we were lucky because when we started this, it was before we had the techniques where you could run DNA and characterize who were there with a fairly good precision. We were going into this in a period where there was some kind of a method limitation, and as a consequence, we had to look more on the functionality and what type of processes that he wanted and what type of processes we don't want to have. And maybe I can compare it. If you have a leakage in your water supply, you ask for a plumber. You don't ask for a name. You ask for someone who can do the job. Whether the name is Natran or Olav, it doesn't matter as long as the person can do the job. And I think this is where the challenge is now and where we need to develop more knowledge. Like Kari said, we need to know what we want to avoid, what type of processes we want to avoid. And the next thing is we want to know more about what type of processes that we want to have running in the systems, what is critical for the health. And you know, these microbiome things and also microbial management, it has accelerated a lot. And for humans now, they have billions and billions of euros available funding. We have nothing compared to this. In human health, they are not able to give any names for what is a good thing. And they have even shown that healthy humans, even healthy twins, have different microbiota, but they are still healthy and good. And I think there was a famous Russian author who said something like every unhappy family is different, but the happy families, they have all something in common. But I think when it comes to agriculture, maybe it is a bit different. There are not so many ways to get unhappy, but there are very many ways to get happy. And I think the main thing is not the names, but the main thing is what they do.
Okay. Kari?
Yeah, I totally support what you have said, of course, before, both Peter and Olav. But if I can try to make it more kind of simple and concrete for you, and I would do that. I would try to say that if you should go for something, go for stability and try to keep the organic matter low but stable. So it's to make it really simple and boil it down. You don't have to know so much about the microbes, but it's about to make a competition that is stable and make them fight for the food. That is what. If you do that, it's hard to do something very wrong. Of course, also you need to have biosecurity coming in. But if you can set up your system to work like that, I think it's very hard to do anything wrong. Also, you can add the probiotics or you can not add probiotics, but still, if you can maintain it like that, I think at least you have come a good way.
Okay, all right. Okay, understood. Okay, now the next question is on the role of live food, all right, such as algae and zooplankton. For example, microalgae seems to have an effect on the type of bacteria, that are dominating the system. So is there any, have the any speakers or panelists notice any differences when we use different types of algae in the system? For example, differences when we use the green water or the brown water. And I even noticed that Robin just now, for example, used mature water with diatom with it. Can you share your experiences on that when using microalgae? Yes, Olaf? Olaf, you need to unmute yourself.
A little bit. I don't have a lot of experience with different types of algae, but a few different types. And my experience seemed to be the main thing is to have some normal non-toxic algae. And then 2 of them that is not the most critical. So there, if people have more knowledge, they can probably find some algae species that is better in one situation than the other. But I think in general they have a positive effect on the microbial environment, and it really doesn't matter who is there. My experience is that live algae is better than if you add some of this algal paste, which is in. They don't have the same function because they are not alive.
So
Yeah.
Patrick,
If I may add here, indeed there is, there was your PhD, Natra, and there are other studies that indicate that there is an interaction between the microalgae and even the macroalgae and the microbiome. We still need to learn more about. But what I like to mention here is that we often see that people do not realize that live food can also be the carrier of Vibrio. And that live food, if not produced under the right circumstances, so this is where a couple of the speakers have been referring to, algae, when they are harvested in the exponential phase, fine. But many farmers, they want to have the maximum out of their algae culture, and they are waiting until just the end of the exponential phase. But that's a moment where you have already mortality in your algae, and that means substrate for bacteria. That means dissolved organic matter for Vibrio development. So there are two sides on the coin. We need to learn more about what is the impact of macro and microalgae on the microbiome. And then second, microalgae and live food should be produced under biosecure conditions. I cannot underline it enough because, for example, people switching from indoor to outdoor production of algae, in a number of cases, I remember that bioluminescence could be correlated with the place where the microalgae were produced.
okay, right. So we need more study on that. All right. So next is on the new disease, which are, basically found that many of them are caused by microbes, and which are booming in aquaculture recently. There is also literature on the occurrence of antibiotic resistance in probiotic. So is there a possibility that microbes, including mature microbiota, can somehow backlash and become a pathogen?
Maybe I can comment a little bit on that. Yeah, I think when you use the microbial ecology to control, it means that you are changing, like Peter said, the conditions, and you are welcoming all the different species and you are making them compete. So it's, I think, the opposite of what you are doing with antibiotics when you are killing everything and you are making less competition. And also where you make it very favorable to be the one that can fight it. So I think it's not very dangerous when it comes to the microbial conditions that we are going into resistance, because we are working on the ecology more. And also the goal must be, I think, to use less antibiotics. And Olav have done some work earlier that shows that using microbially matured systems is actually the same good effects as using antibiotics in some cases. So you can exchange that for using microbially matured and probably more safe than antibiotics.
Okay. Olav, you want to add?
Just as a small comment on the development of antibiotic resistance. As Kari said, the rule number one should be to have a practice where you can avoid it. And there is a very good example in Norwegian salmon farming. They only use a few grams or per year. Then, of course, antibiotic resistance, it can travel horizontally, so it can be genetically exchangeable elements, but to keep this element, it has some costs. And I think in a situation where you do, as Kari said, to make sure that there is always strong competition for the organic matter available there, then to maintain this antibiotic resistance genes, they will probably be, they have some cost, and as a consequence, these microbes will probably be less competitive under a situation with very strong competition. So I think it's something you should be aware of, but I don't think the risk is very big.
Okay, all right, okay. Okay, there is more on the general question. I also received some technical questions from the attendees. First is on the possible use of bacteriophage therapy in microbial management system. Any possible use using bacteriophage therapy? Yeah, Peter.
Yeah, I don't. The use of bacteriophages, it's something relatively novel. And for the people who don't know about bacteriophages is viruses that infect bacteria. And this is a kind of thing which is coming up also within the aquaculture industry. And in that sense, I would say that the use of phages, it is a kind of microbial management strategy. It's not something that can be achieved by having changing parameters and so on. Of course, if you change the conditions, some number of bacteria will increase in numbers and you will have more phages because the phages are linked to the bacteria. But in the context that we are talking about, changing how much water is replaced, how much nutrients are added, and so on, it will not have a direct influence, as I would see it, on phage numbers in the sense that we would use them as a microbial management strategy.
Okay. All right. And then another technical question of using oxidation methods for reducing nitrate in pond. Is it good? Probably Manuel have a explanation for this oxidation method for reducing nitrate in ponds. What is the extent of using oxidation method for reducing nitrate in ponds?
So, sorry, you're talking about reducing nitrite.
Nitrite, yes, sorry, nitrite.
Well, in my experience in the farm, the only thing that has been working in reducing nitrites in my conditions are nitrifiers.
Okay.
So, and this was very robust. And if I look at the different presentations, it seems that when we talked about case strategists, we talked about biofilters. So I understand that when we don't work together, they are still working in the similar communities about the nitrification bacteria. Okay. So their power of digesting nitrite is very high. And if I want to read a little bit the nitrogen cycling that we have in our shrimp ponds, I will tend to think that actually when you start a ponds, there's nothing you can do about the development of nitrifiers. They will become part of the communities. And you know that there's two communities. There's ammonia oxidizers, nitrite oxidizers, and the ammonia oxidizers are fairly quick to establish in the systems, you know. And I do believe that when you start a shrimp pond using carbon or not, you will still have ammonia oxidizing bacteria that will go into your ponds. And I really do believe that this is these ammonia oxidizing bacteria that are producing the nitrite that accumulates. So this to me have nothing to say with the use of carbon or heterotrophic. So, and it's something it's barely unavoidable. And I don't have a huge experience in RS systems, but I will tend to believe that if the biofilter of the RS system is not well dimensioned, you will have the same nitrite spikes problems. So the conditioning nitrification bacteria means that you have these spikes of ammonia and nitrite with no shrimp. And you're conditioning this, like this biofilter, it's all running, all mature, and using this because I've seen that even if you're doing a little inoculum of 1% or 2%, depends on digestion rates that you're achieving in your biofilter, like carrying capacity. But if you do that, these nitrifiers can establish well in a pond over time. And to me, this has been the only way for me to fix nitrites problems. I have never found any other tools being able to be so efficient.
Okay, I see Robbins is also raising his hand.
Well, we'll see. For me, if there's nitrite problems, you've got a reduced area of the pond someplace. Generally, when we go through the nitrogen cycle, everything should go to nitrate, but oftentimes it'll go up and then the nitrate will even out and you'll actually start seeing some increases of nitrite. That's because this pond is no longer oxidized. There is a reduced area, there's sludge on the bottom, there is a problem area in the pond. If your pond is perfectly clean on the bottom, you have no reduced areas, your nitrate will continue to go up and you won't accumulate nitrite. But nitrite almost always, in my experience, is associated with a bad bottom or a reduced area in the culture system.
Okay. Carly, you want to add?
Yeah, from the RAS perspective, we know that, for example, if the question was about adding oxidants, it may actually be an option to add ozone or hydrogenic peroxide or something like that. The problem is because in theory that can oxidize the nitrate, so it could be like a help. Your problem is that when you have the nitrate problem, like you said before, Robbins, there will be a lot of other problems with the water quality, which will eat up the oxidizing compound. So you will have to add so much to, so it's not going to be a practical solution at all. But in theory, you could add an oxidizer to help you to get these nitrate peaks down. But in reality, it will not help because there will be so much consuming that oxidizer. So it's better to look at the microbes and look at how their conditions are to help you to get rid of it instead of thinking to add something.
Okay.
Just wanted to add something here, and again, just sharing my experience there. When you're conditioning nitrifiers, everybody that's worked with a biofilter knows that it can take a long time to have nitrite oxidizing bacteria in your biofilter. And what happens in the ponds I have been monitoring is I do believe that when you're making water exchanges, try to control your nitrite, you're basically washing up the nitrite oxidizing bacteria, try to establish. So everyone has his own experience, but in my experience, I have nitrite accumulation in ponds that have zero organic matter accumulation or zero leaks, and this was linked to this establishment of nitrifiers. So I suppose different conditions, different experience. So yeah, just wanted to add this comment.
Okay. Olav, I also see you raise your hand. And Peter, do you have anything to add?
At least we see that in some cases where there is accumulation of nitrite, it is because we have mature nitrifying biofilters. Because in some cases, the nitrite oxidizers take a longer time to develop. And at least in some situations, especially where we have had some changes in the environmental conditions, like changes in salinity or things like that, then this is very often related to an unbalance. This is just to add on something extra compared to what Robin mentioned.
Okay, all right. So Robin, you do mention about the need to really remove the sludge. So we do have questions from the audience. How do you actually eliminate sludge collected from the culture tank? And do you reuse it as a fertilizer or anything?
If we're talking about culture tanks, I assume we're talking about pond shrimp. And that's where the toilet has become a very effective tool in accumulating the sludge around the center, at which point it can be pumped up and out into a collection area, or it can be pumped down and out to a collection area. And depending on the buildup, you can be removing it every 5 minutes, every 10 minutes, or once a day. So as the culture matures, you get more and more food input, more and more sludge accumulation, you basically set the timer on your toilet to flush more often. Because really, if you want to improve growth, you keep the bottom clean, you keep the system oxidized, and you'll get the best growth. But if you have accumulation outside of disease, if you have accumulation on the bottom of sludge and a reduced area, shrimp do not grow that well.
Okay. We have questions here on, because we have here shrimp specialists just now talking on biofloc system in the outdoor system, and also indoor RAS system. Any advantages or disadvantages, between this system? Which is better? Oh yeah, I can see both are good actually. But maybe manual, or we can hear also from Pam if we have any challenges or difficulties in maintaining this system, the biofloc and also RAS system.
Okay, thank you. For the outdoor pond, I think we need to balance the condition and ecological system. That I show you that we use a lot of several species and do integrated system. So the challenging is it's quite difficult to control the weather and the others. So the farmers have the require of like a sophisticated technique, has experience, and also more offer to reduce load of organic matter. Also to have the waste management is the key success for the outdoor shrimp farming in the recirculation system.
Okay. I can see Robin's also raising his hand.
Yeah, I think the comment is basically on flock, it's autotrophic or heterotrophic. And for me, I started with heterotrophic flock, and everybody is still on heterotrophic flock. Heterotrophic flock is dirty, it gets diseased, it's reduced, it's not the best flock. Autotrophic flock is the way to go. It's a light flock. Most people will look at an autotrophic flock pond and go, there's no flock. Actually, it's a very efficient flock that basically doesn't dirty the pond and allows the pond to stay oxidized. And so you're going to get your best growth and fewer programs. But heterotrophic flock too oftentimes goes bad. It actually reduces the growth rates.
Okay, all right. Okay, since we really running out of time, I can just take one more question. Okay, do you think microbial communities both in water and host could affect the host quality in terms of taste and texture? Basically, the people, this is from Dr. Madalena, okay. So they have basically tested different production system, and they saw differences not only in productivity but also the shrimp metabolites, profiling and sensory evaluation. So have you had any experience in terms of whether the microbes in the water could affect taste and also texture of the shrimp?
For me, I think that maybe it can indirect effect, like it can do like a pre-digest to the feed that a shrimp eaten, and this can release some nutrients that more effectively to shrimp to digest and use it, and for the metabolites, I think.
All right, Peter, you raise your hand.
Yeah, because I think it's an interesting question. I have no experience with it myself, but I can imagine that there might be some influences there. If you look at some species of bacteria or microorganisms which are responsible for off flavor and so on in fish, I can imagine that there might be some possibilities that it also has an effect that changes substantial. Huge changes in microbial communities have an effect on taste, but to my knowledge, I don't know of any specific cases where the differences would be so big that it results in shrimp not being accepted by the consumers.
All right. Okay. Patrick, you want to comment?
I think Robbins is before me.
Oh yeah, Robbins.
Oh, I didn't even know I was supposed to comment. I will say off flavor is a big problem in shrimp. So there are certain conditions where you get a blue-green algae or you get a fungus or you get certain bacteria that give off flavor, and those shrimp are totally unmarketable. And so if we're looking at that as microbial, yes, microbes can influence the economics of a shrimp farm in terms of the quality of the shrimp being produced.
It was the same comment I wanted to make, so.
Okay, all right. I think we really running out of time now, so I think we have a webinar. That I would like to personally thank all the speakers for the very insightful discussion and all attendees for the participation. But before we end the session, I just want to share with all of you on the next WAS meeting, which will be in Singapore in December 5th and 8th this year. So all are invited, okay? And just before we leave, can I ask all the panelists to stay behind just to have a group picture? And thank you from me. Thank you everyone for the nice talk. We actually have a lot of questions, but it's really hard to address all of them.
Thank you. You did a great job. It was nice.
Okay, Nate, are we ready?
Okay. 1, 2, 3. All right.
Okay, all right. So I'll see you again in the next webinar, perhaps. Thanks for giving a nice talk presentation. It's really late here in Malaysia. It's time for to break my fast. I'll see you again.
Thank you very much.
Thank you.
Okay.
Yeah.
Bye.
Bye.